Hello everybody and welcome to my YouTube channel. My name is Michael and this video is about a machine I bought 4 years ago, a mini mill from Precision Matthews. The model is PM-25MV, and I want to share my experience with installation and setup of the machine, and also inform you about a few additions and upgrades to the machine which I believe led to good improvements and made the machine better fit my needs. First step, installation. The common process, also recommended by Precision Matthews, is that you put the stand for the machine at its final location. Then you lift the machine with an engine hoist, move the machine to the stand, drop it on the stand, and you're good. I did it a little bit different. I did not want to get an engine hoist. They're kind of big and bulky and take up a lot of storage space. So what I did, I built my own stand, put it on casters, which can be removed at a later stage. And then I lifted the machine after unpacking with my electrical hoist, which is mounted to the ceiling, moved the stand underneath the machine, dropped the machine on the stand, and then moved the complete assembly, machine and stand, to its final location. Lowered the casters, dropped the machine on the floor, took off the casters and bolted the stand against the wall for a more stable setting. That's how I got the machine from here underneath my electrical hoist to here against the wall. Next, the stand. The machine, or the stand provided by Precision Matthews, has a little bit of smaller footprint. I believe it's a good stand to have, but it does not offer plenty of storage. So I always want to keep all the tools and everything I need to working with a machine close by. So I built my own stand to have enough storage room for tools and 1, 2, 3 blocks and everything you need for milling. And let's start with the stand. It is based on a 5-drawer work chest from Yukon. As I said, 5 drawers for measuring tools, parallels, 1, 2, 3 blocks, and so on. Below here is a larger compartment for rotary tables, angles, and so forth. On the left side of the stand, let me move the camera. On the left side here, I installed racks for R8 collets, a box for 5C collet, for a 5C collet block holder, a rack for additional tools like chuck and boring bar and a compression, tension, reversible thread mill holder, and all these things. Down here, the fixtures I need. In the front of the stand, I installed a little board which just pops out. Then I can place my measuring tools, calipers, and so on here, fold away. And to the right of the stand is a vacuum. It's permanently installed here. Then an MQL, a micro quantity lubrication system, which I designed on my own. It consists of a nozzle which allows you to adjust airflow and flow of lubricant separately. The little blue thing is a 3D printed holder. You can attach that with a magnetic stand or directly to the spindle or to the quill to get cooling to the cutting tool. This is a pressure container for cutting fluid and a power regulator which cuts back the air pressure. I normally run about 120 psi, cuts it back to about 20 to 30 psi, suitable for this nozzle. Up here, a DRO. I ordered this DRO from Precision Matthews and it was pre-installed. Moving up to the table, on the left side is a power feed For the y-axis, it is pretty self-inflating, has a little rapid button here. Works great. The only thing I would probably change is this dial to adjust the feed speed is a little bit light. I would like to have a little bit more friction to prevent me from changing the speed while cutting. It works, but that should be changed probably. The bed itself is protected by two plates that just pop in and out to protect the bed if anything falls on it, and also to prevent chips from getting into these T-slots, which is kind of covers on to clean. So they just pop in here. There's this little shape here to fit exactly in the vise that no chips get through. Also on the table there is there's a limit switch for the x-axis, so that you cannot run with a power feed, that you cannot run the table into something which is expensive. The limit switch comes with a plastic cover here, and the problem is that's a kind of big cover for the small switch, and when you move the table in Y towards the handle, this cover at a certain point hits the handle and limits your Y-axis movement. So I didn't like that. I took that off. The cover, created my own little cover, and now I have about 3/4 of an inch more Y-axis travel in that direction. Something similar is true for the back here. This rubber cover was attached to this protection thing here with a metal angle, which prevented the table to go all the way back in this direction. There's also the sensor for the DRO is placed back here. So what I did is I just rearranged it a little bit, took off the metal angle, built something on my own. Again, adding about 3/4 of an inch in Y movement, which is for a small machine very important. So moving up to the lock screws. The mill has, of course, lock screws for all 3 axes, and on top of it for the quill. They normally have these threaded levers, and they are a little bit, let me move the camera here, they're a little bit big for this machine, so they're always somehow in your way. And another issue is that for the headstock, they're located behind this control box back here, so they're out of sight and they're kind of hard to reach. So what I did is I took them out, took these out, and replaced them with 8, a little bit bigger, 9mm rods, put 8mm threads at the ends, put a little aluminum knurled wheel on here, and they are spring loaded inside here. Let me show you that, probably you can see that. See, here they're spring loaded here to prevent them from vibrating or rattling when they're not tightened. And now it's much easier to reach that here. Everything's inside, easy to reach. Same is true, of course, for the X-axis locks, also spring loaded. And then there are 2 more underneath the table here for the Y-axis. The knobs down here are a little bit smaller, but otherwise design is similar. Also put a little piece of sheet metal right underneath the table, because the table underneath is always a little bit oily and greasy. I always have dirty hands, so this prevents me from dirt and grease and stuff like that. The mill comes with a DRO for the quill. That means you can measure the depth of a cut or the depth of a hole when you're drilling by watching this little digital display. You can set it to 0 at any point you want. You can switch between inches and millimeters, so great feature. What the mill does not have is a Quill stop. That means every time you drill, if you want to have several holes of the same depth, you have to watch the DRO and then stop pushing down when you reach the depth. So I designed a Quill stop where you can adjust this knurled aluminum wheel to a preset height, and then the Quill stops when this aluminum wheel hits this holder here. It is the threaded rod is attached to the base plate of my spindle stop, to which I get a little bit later. That makes this little threaded rod move the same way the Quill does, and you adjust this wheel to a preset depth. It's a little bit cumbersome to turn this wheel all the way up and down, so I designed a little push knot where you just press this button and then you can move it up and down, and then you just fine adjust by turning it. Works great, so every time you drill a hole you have a preset depth, and then it's very repetitive and you don't need to watch the DRO all the time. Attached to the headstock is this chip guard, which typically slips into this housing, and it's mounted here to the left side of the headstock. So it prevents chips from flying in your direction. And when you open the guard, the little micro switch in this box turns off electrical power to the spindle motor, and the spindle stops. So I didn't like that too much. I took that apart and placed a magnet here. I can just place it here if I want it, adjust the height whatever I want, can place it in any direction I want. It works great, and if I don't need it, I just place it up here. There's a little rest for it. And I use the cables attached to the micro switch, which turns on the turns off the motor. I use those cables or this electric circuit and use it in my spindle stop to prevent the spindle from spinning when I engage the spindle stop. I get to that a little bit later. Unfortunately, the mill does not come with the spindle stop. That means that every time you want to change a tool, you take this big wrench, turn the spindle in a direction where you can hold on to these two flat spots with your wrench. Hold on to this big wrench, take a smaller wrench at 10 millimeters. There's a little square on top of the drawbar. And then you loosen the drawbar by holding on to this wrench. And a little bit more. And the tool comes out. And to reinsert the tool, do the exact opposite thing, or the same thing in reverse. Just turn the spindle to position to get a hold on with this wrench. Hold on to it, and then tighten the drawbar. And you're done. This is quite cumbersome if you have to change tools or not. So what I did, I designed a spindle stop for this machine, and that allows me to stop the spindle from turning the moment I slip this lock pin into a collar down here, which is 6 holes, and the lock pin just slips into one of these 6 holes, holds on to it, and now I can change a tool by just inserting this guy, open the drawbar, tool comes out. To reinsert it, just put it in, switch the direction, and you're set. Much faster and enjoyable to work with. The exact design and the parts for the spindle stop I will discuss in a little bit in Fusion 3D model. And it is the parts I have here is a locking pin, which has a groove here and a micro switch. So before I can move this pin, I need with my thumb depress a micro switch, which lifts it out of the groove, and then I can move this pin freely. And when I let go of the micro switch, it's locked. So I cannot engage this pin into the collar when the micro switch is not depressed. That avoids you from starting the engine when the spindle is locked. I used the same electrical circuit which was before used to safeguard the chip guard, that you could only operate the machine when the chip guard was closed. I disconnected that, connected it to my micro switch, and it was great. Very helpful, saves a lot of time, and much more fun to work with. This is a Fusion 3D model of the headstock with the quill and the spindle. The spindle has two flat spots here to the right and the left. That's where you place the wrench to prevent the spindle from rotating when you're tightening or loosening the drawbar. I added a spindle ring. The spindle ring has 6 holes in which the lock pin, which I show you later, engages, again to prevent rotation of the spindle. The spindle ring is held in place with 2 set screws here, one in the front, one in the back. And these set screws pretty much only prevent the spindle ring from slipping up or down on the spindle. The torque forces are taken up by these 2 segments here to the right and the left, which engage with the flat spots. The base plate is the attachment point to the lock pin housing. I'll get to that in a second. It clamps onto the quill and also has mounting holes for indicators and so on. Next part is the lock pin. This pin moves in this direction and to prevent rotating of the spindle engages with these holes. I'll show you that real quick how it works. So you push the lock pin inside to stop rotating and pull it out to allow rotating. This is the lock pin housing here. And this is a safety switch. It's a micro switch which engages in this groove. That means when the micro switch is out, it engages in this groove. You cannot push the pin in when the micro switch is out. That means the micro switch allows the spindle to be turned by the electrical motor. And as long as that's the case, you cannot push the pin in. If you press this little micro switch with your thumb, it disengages from this groove, and then you can move the pin, and pushing this micro switch disengages the spindle motor. So that's a safety switch. You can only move this pin when you disengage the motor first. You don't want the motor to work against the locked spindle. I also attached a Quill stop, which is unrelated to the spindle stop. That is something to limit Z travel to a preset distance. So that this is a nut or wheel which you can move up and down on this bolt, and then it limits the Z-axis travel. To adjust the height of the tailstock, you just use this hand wheel and crank it up or down. It works perfectly fine. The issue is if you go from a very short to a very long tool, for example, a chuck with another 3 inches of drill sticking out, you crank that thing a lot. In order to make life a little bit easier, I added a power feed for the Z-axis. Here we go. There is an electrical motor with a planetary gear set, which is attached then directly to the lead screw for the Z-axis. And when you press the button up, it does that thing automatically for you. One tip, if you ever build one of those, try to find an electrical motor with a planetary gear set. Normally they are sold with a warm drive. A warm drive is great and works perfectly fine for many applications. In this case, it's not the optimal choice for one reason. If you use a warm drive, you won't be able to crank the headstock up or down by hand. I wanted to maintain that feature, so I still can use both. The force to do that is a little bit higher because you still need to drive the engine or the motor right now, but it's insignificant, works great, and otherwise just like that. So keep in mind, planetary gear set, no worm drive. The activation switch for this feature is right here next to the headstock. Built a little 3D printed a little housing, has a little LED to see if the power controller for this unit has power, and then you just press on the down button and the up button. So here's a 3D fusion model of the headstock column. The headstock moves in these grooves up and down in Z direction. Here is an opening for bearing where the hand wheel shaft goes through to the lead screw. To take the column away, inside there is this gear wheel. The hand wheel is attached to that, and the gear wheel is attached to the lead screw with a washer and an 18mm nut. Take those away, and I replaced them with a different washer and a coupling made of brass. The coupling has an inner 18mm thread, screws onto the lead screw, and is secured with a little set screw here. On top of it, sliding into this coupling, is the coupling to the motor drive shaft, again made of brass, secured with a set screw here. And then here is the drive shaft, safety ring, motor axis sleeve, motor housing, and the mounting plate of the motor. This mounting plate attaches to my homemade base plate, which then attaches to the top of the column. So this is the complete assembly of the engine, the mounting of the engine to the head of the column, the couplings inside, and how the coupling is attached to the lead screw. What's missing here then is the shaft to the hand wheel. Here are 3 pictures of the assembly. The first one is a view from the top of the column inside with the gear wheel and the lower bushing attached to the top of the lead screw. The second one shows the lower and the upper bushing. And the third one, the 2 bushings, and on top of it, the electrical motor. Okay, we're coming close to an end. The rest is just more or less sugar coating to allow for maximum travel in Z direction and avoid collision with the shelf I had built up here just created a little cutout which you can take out. That gives me then more movement in Z. I added a magnetic board here which allows me to put on drawings, etc. I can see them while standing in front of the mill. Added a light strip. I just didn't turn that on while filming because it interferes with the lighting for the camera. And that is pretty much it. So thank you very much for your attention. I will follow up with more videos about other machines and how I upgraded them. But I will also finally put some videos about actual projects I built with these machines on YouTube. It's not just that I'm upgrading machines, I also actually build sometimes something usable. All right, thanks again for your attention, and I'm looking forward to see you very soon. Thank you.